Now let's pick up where we left off yesterday. Identifying parent functions to model data sets. So first we have this table. We're going to graph the data from the table, describe the parent function, and the transformation that best approximates the data set. So first let's graph this data. So I'm going to draw some lines in. If you go online, you can print graph paper if you have access to a printer. You can also just go to the store and buy graph paper. They carry it pretty much everywhere, Staples, Walmart, all that stuff. So those are always some options. So I know I'm going to need to go back to -4 and at least over to +4. This is going to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. See, I'm perfect and I didn't even realize it. So my first point is -4, 8. So I go back to -4 and up to 8. Next point is -2, 2. So I go back to -2 and up to 2. Then I have 0, 0. So now we plot our next point, 2, 2. There, and then go over to 4 and back up to 8. It's obviously not perfect. And we're going to draw a line between our points. How careful I'm being. Got ugly on this side. We can tell what general shape that is. That is a parabola or a quadratic for the parent function. Now we need to figure out how it's being altered, right? It says the transformation that best approximates the data set. So if we're trying to figure out how that's being altered, we need to know what the original one looks like. So if I put x squared in, I'm going to find out that it comes up to 1, 1 and -1, 1. Goes over to 2, comes up to 4, over to -2 and up to 4. Then at 3, it goes up to 9. And in -3, it goes up to 9. So you get the general idea here. This one is definitely wider than the other one is. So what I need to realize is this is going to be a horizontal compression. I'm sorry, a vertical compression. Could also be a horizontal stretch. I'm pulling it out wider. And that's it for that one. Let's try this one. We have 0, 0. It's our original point. 2, 6. Just expanding that out for my points. So I have 2, 6. And then 4, 12. And then if I look at the other part of this, negative 4, negative 12. It's going to be down here pretty far. This would be like down here, and negative 2, negative 6. I can already tell some of you are looking at me going, or looking at these notes. You're obviously not looking at me since we're not here, but you're looking at these notes and you're going, man, this is too much work. This is ugly. I can see it's a straight line. But remember, if you look at your extra help items, I put a graphing calculator on there. So all you would have to do is put these points into the graphing calculator to see them. And so if I went ahead and opened the Desmos calculator, I can see that stuff. So I can see that using Desmos. And just plotting points like negative 6, negative 12. And I need to put parentheses around these. You'll notice that if you don't put parentheses around them, a little like hazard box comes up. I remember 0, 0 was one of my points. I think it was negative 2, negative 6. And then 2, 6. And 4, 12. That one had been negative 4. And this is 4, 12. Sorry about that. So whenever we look at this, we now see that that forms a straight line, which tells us that our original function was linear. So then our parent function is linear. So we type in y equals x. If that's my line, what's happening to my line in comparison to my dots? See, my dots are more steep. They come through the same central point, 0, 0, which tells us that this is going to be a vertical stretch for my transformation. So just looking at it on the graphing calculator makes it much easier to see how my data points fall in comparison to the parent function. Now, if you were doing that as a homework assignment, you could export that graph to me as an image. Tomorrow we'll pick up with word problems.